In this video, we're going to talk about how to express functions as a series or as a Taylor-Maclaurin series. So as sum of an as a function of x. And we're also going to talk about what the power series is. So the power series, let's talk about the power series first. The power series is actually a special case of the geometric series. So instead of having a fraction here that is less than 1, we have instead a variable, and we know that x has to be that the absolute value of x has to be less than 1, because that's the condition for our geometric series to converge. And we also happen to know the sum of our geometric series, which we know is a over 1 minus r. Right? And so in our particular case, our a is equal to 1, so we get 1, and then 1 minus, and our r is equal to x. So this series is known as the power series because it is x to some power, and we know its exact value is from when we sum from n equals 0 to infinity is equal to 1 over 1 minus x. So now how do we use this in order to express certain functions as a series? Well, remember when we said that we want to express things as a Taylor polynomial because they're easier to manipulate? For example, we know how to take the integral of a Taylor polynomial. We know how to differentiate any polynomial, and we can also multiply any polynomial by x to some power, because that will still produce a polynomial. So for example, say we have the function x squared times ln of 1 plus x. This function it's slightly difficult to work with if you didn't know what if we wanted to integrate this function, it would be difficult because I don't know what the integral of ln of x or ln of 1 plus x is. However, we can say that x squared to the power of x squared times the ln of 1 plus x is equal to x squared times the integral of 1 over 1 plus x dx. And what we know about 1 over 1 plus x is we actually know 1 over 1 plus x is the same thing as writing 1 minus negative x. 1 over 1 minus negative x. And if we instead of writing 1 over 1 minus x, 1 over 1 minus negative x, we can actually write x squared times the integral, the sum of n equals to 0 to infinity of negative x to the power of n, which we can then, or not simplify, but which we then want to split into negative 1 to the n times x to the power of n. And then from here we can integrate. So we would integrate this like how we integrate every other integral. We would have negative 1 to the power of n is a constant, so we just have a sum n equals 0 to infinity of the integral of x to the power of n is equal to 1 over n plus 1, 1 over n plus 1, and then x to the power of n plus 1. Yeah. And then from here, we can multiply our x squared into the series to get sum of n equals 0 to infinity, 1 to the power of n, 1 over n plus 1 times x to the power of n plus 3. And so this is equal to x times ln of 1 plus x. Obviously, this series has to converge for this to hold true, because we know that this function has a value for for values of x that are non-negative, and for when ln is defined.